This is Chapter 9, Enhancements. This is a really dense chapter. Some of it covers enhancements that are strictly for fun and for teaching purposes. And some of these enhancements aren't really enhancements, but make the difference between a really addicting, playable game and a game that you're going to get bored of very quickly. The main weakness in the game right now is, of course, the fact that the pipes simply move straight across, so it's not very challenging. So the most dense flow graph that we're going to deal with in this chapter is going to move those pipes up and down. But the first thing that I want to do in this chapter is simply hide the terrain and move the ocean up a bit, because we're going to end up animating this game over text and making it fall into the ocean just for fun. So I'm going to go to my terrain editor here, and I'm going to change the height of the ocean. Instead of being way down at 16 meters, I'm going to use Set Ocean Height under the Edit menu. I'm going to bring it up to 30 meters. Also, I don't want to see the terrain anymore. I don't need it. I can hide it here in the editor, but that's not going to hide it in the game. I'm going to have to set a CVAR for that. But we'll see this right here. I turn this off, and there's my water kind of ready to go. To hide it in the game, I want to do that on Game Start. I'm going to use another one of these console variable nodes, so I'm going to copy and paste this with links. So this is already here. And the one that I'm looking for is called E_terrain, this guy right here. And I want to set that to 0. And just to prove to ourselves that it's working, let's enable the terrain right now. Save and test and die, and we should see game over after 1 second and the ocean waiting below it. The next thing I want to do is create some difficulty to the game that varies dynamically. Specifically, every time the player scores a point, the game gets a little harder. And the way that we're going to vary the difficulty is, first of all, the horizontal pipe speed. Instead of it being static 5 meters per second, we're going to make it faster and faster every time the player scores a point. We're also going to start moving the pipes up and down, which is going to take some doing. So we also want to create a variable that sets the range of vertical motion. So of course we're talking about game tokens, which are in the database. So let's go ahead and add one that's just generally a difficulty level. I'm going to use this global difficulty setting to drive a lot of other things in the game design. I'm just going to randomly assign 1, 2, 3, and 4 for difficulty levels, where 1 is easiest and 4 is most difficult. I'm also going to create something for pipe speed. And here, I don't want to be forced to increment by an integer value, because the game would start to get really fast really quickly. So I'm going to make this a floating point number. I'm going to call this horizontal pipe speed. And again, get in the habit of setting the data type right away before you forget. And lastly, I'm going to set a range of vertical movement in meters. And for this, I think it's okay to do an integer. I'm going to call this vertical pipe movement. I know I'm going to need to initialize these game tokens. So the philosophy that I'm taking here is that ultimately I'll have a UI menu, and the player will be prompted to choose a difficulty level, 1, 2, 3, or 4. And I want to base my horizontal pipe speed and my range of vertical movement on that single variable. I don't have a UI menu yet, but I still need to initialize my difficulty setting. So I'm going to do a game token set, and I'm going to do that on game start. Not super happy with where I've got my game start. I think I'm going to move it down a bit since I'm accessing it through so much in this section. Could also just make a copy of it, make another one. The token that I want to modify is my difficulty. And then it's going to be 1, 2, 3, or 4. I'll say, I don't know, 3 for now. But this will be driven by a UI menu later on. Now, based on this value, I want to choose one of 4 possible values for the pipe speed and also for the vertical range, since I have 4 possible difficulty levels. So I'm going to do 4 more game token sets. Get rid of this. But in this case, I'm going to start with pipe speed. And then add another one of these. And this one I'll make, I don't know, 4 meters per second. I copy both of these, paste 2 more of them. I'll say 5 meters per second, and then the ninja level, I don't know, 7 meters per second. So now the trick here is that I have to get from one node, one output value, and pick one of these based on this number. And that's a little function we call multiplexing or demultiplexing. And that's going to be under my logic group. And in this case, I'm looking for a demultiplexer, which takes one value, and whatever that integer is, that chooses the port here. So I'm going to feed it into index or input. It doesn't make any difference. You just have to make sure that you tell it to monitor both or whichever specific one you're using. So if it's 1, it's going to go to port 1. And I want to trigger this guy and set my pipe speed to the lowest possible value. If it's 2, that's a little harder. I choose this guy, etc., etc. The rest of these ports I'm not using. That's going to set my pipe speed. And then I can just build on that rather than multiplexing all over again. I'm just going to copy and paste another set of these. And this is going to be my range of vertical movement for my pipes. Might have been faster to do this way first. I think I'll do that. Mapped the wrong one there. Let's say 5 meters of randomization. Make 2 more of these. Copy and paste. Let's say 7 meters of randomization, and the ninja level is going to be 10 meters of randomization. So a pretty big difference between these. I hope this makes sense to you, even though we don't have this menu yet. The point is that I have one setting that's going to drive a whole bunch of settings that are all ultimately going to affect difficulty. Now that I have those values initialized, and now I'm ready to go and modify my pipe movement and drive it with those variables. So the first thing is I have a hard-coded speed in here, and I'm just going to get rid of it. Wouldn't really matter because I'm going to feed it a node value that would override it anyway. I know this is going to get a lot wider, so I'm going to move some nodes around here. And the first thing I'm going to do is say, what is the value of my horizontal pipe speed in any given moment? And I'm not going to trigger this manually. I'm going to do it on every frame because this is going to change every time I score a point. So that output is going to become my speed. Just going to keep that monitoring on all the time. That's pretty straightforward. The next thing is that I need to go and actually increment my speed every time the player scores. I'm not going to add an integer value because it would get too difficult too quickly. I'm just going to add 0.3 meters per second every time we score. So every time one of these score triggers is touched, this adds 0.3 meters per second to my horizontal pipe speed. So it keeps that value dynamic. The next thing I need to do is add a random vertical position to my pipe. There's 2 ways to approach this. Here's my AI start. Here's my AI end. The pipes simply move straight across. If I change the Z value relative to either one of these, the pipes are then going to drift upward or drift downward. So that would already give me randomization. If I wanted to be really tricky about it, I could make that happen multiple times during this journey from here to here, or from their first position to their last position. In other words, a kind of a sine wave that's unpredictable in how high it goes. Since that's obviously more complicated, all I'm going to do is add a random value to the Z value of my AI end and my AI start, randomizing them separately. So each of my pipes is going to travel across in some kind of unpredictable diagonal line that could be really steep. It could even conceivably be straight across if the randomization ended up being 0. Now that I have those values initialized, I'm ready to put them to use to affect my pipe movement. So specifically what I want to do is change this destination. Instead of simply traveling to the position of AI end, I want to add or subtract a random value just to Z here. So let's make a lot more space. This is going to get a lot bigger. And since we know we're going to need to insert a bunch of stuff between the existing AIN position and when we feed it as the destination to the move entity 2, I'm going to make a lot of space here. So let's try and build this in plain English. I need to take this position and I need to add or subtract a value from Z. Well, we know how to do that. We need to use our friend fromVec3 so that I can separate this into X, Y, and Z. I've got that much done. I'm going to leave this connected for now just to remind myself not to forget when I'm done changing my Z value to feed something into here. And you may find it less confusing to disconnect it right away. So I've split them apart. I know I'm not going to do anything to X and Y. I'm simply going to pass them straight across. So I can go ahead and add a 2vec3 and simply pass X and Y values unmodified straight across like that. Now between here and here, I need to add that range of vertical pipe movement that we created in a game token. So we're going to need to get the value of that game token, and we're only going to need to do it once because it doesn't change during the game. So I'm going to do a game token get, and I'm going to trigger that once on game start. Token that I'm interested in is my vertical pipe movement right here. Now what I need to do is create a random number up to this value. So let's generate a random number. It's another math function, math random. One of the trickier parts about this is being careful about when I generate this random number and start kicking everything into motion that happens after that. So what needs to happen is every time the game starts or the game loop starts over again, right here, I need to generate this random value before I start sending the pipe on its next journey. So I'm going to go ahead and take this output right here and feed that into our generate. That gives me the highest possible value I'm adding up to this number. Let's say it's 10 meters. You could just let the game start at 96 meters high on Z and add up to this value above it. What I'm going to do is add or subtract it, so I'm effectively going to double the range of randomization. But in order to do that, I need to create a negative version of this number. So all I'm going to do is multiply -1 times that. So Q again, and math multiply. So I'm going to multiply this times -1 to invert it and make that my minimum. This was set to 10. I'd say it would generate a random number between -10 and 10. And that has got to be added to my existing Z value. Let's try moving these down here. Again, I'm going to have some spaghetti for a while till I figure out a better way to clean this up. Now that I have my randomized value, let's go ahead and add. So I'm going to go ahead and feed that into there, and then feed the Z value that came from my AIN into here. So I'm adding or subtracting my randomized number, and that is going to become my new Z position. And that, combined with the existing X and Y of AIN, becomes my destination. It seems to make perfect sense, but let's just think through the order of events. So let's say the first time the game begins, we get the position of AIN. That in turn feeds this. It generates a random value. We've also on game start retrieved our range for the randomization. And so all of this has already happened right on game start. We have a destination here. And at the same time, while all that is happening, this is also triggering the movement to begin, potentially before all of this has had time to execute, depending on how powerful and fast the computer is. So that's potentially problematic. So instead of right away when the loop begins or the game begins, after all this randomization is securely finished, then I'm going to go ahead and trigger this. However, that raises another bit of a complication because vec3 has 3 components, 3 numbers, and those are retrieved right away in the beginning of the game. I retrieve the value of AIN, and though it takes time for Z to randomize, X and Y are passed through automatically, which creates some kind of signal which is enough to trigger this to start, even potentially before this Z value has been calculated. So I'm going to make a subtle but important change here, which is I'm going to trigger the retrieval of AIN's position after the randomization. In fact, I'm going to use this thing right here. Now I need to do a bit of cleanup because it's just too confusing looking at it with the nodes the way they are. So let's test this much. What we should see is some kind of diagonal movement on just pipe number 1 right now. I'm going to go ahead and hide pipes 2, 3, and 4 so they don't get in my way, just by clicking and dragging down here. And I'm going to just hit Control P to enable physics, and the flow graph also starts. And you can see that the pipe is indeed drifting upwards in that case, drifting slightly upwards on the second pass. It's not simply moving straight across. Now that we've got that much, now let's randomize the beam back to the start position. You could try and copy these nodes that do the randomization, but if you copy them with these links, obviously the links are going to make spaghetti. They're going to be a big mess. So I'm going to copy them and paste them without links. But before I do that, I'm going to create a little comment box just around the nodes that do the randomization. So I'm going to put my comment box around those nodes right there. So I'm copying. And again, I need to make a bunch of space between here and here. Instead of simply feeding it the position of AI start, I need to insert all that stuff. So I'm going to carefully move my beam entity way, 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 way over. And then I'm going to paste without links, which will give me all the nodes. It just won't have them connected together. So I'm going to take the same approach and actually use this finish to again retrieve my range of randomization. This guy, I'm going to move over to where this one is because I know that's actually where it's going to go. I can get rid of this, delete this, move this down here. That's going to go there. Need to make even more space. Finally have my position calculated. This I don't need. Need to change my comment box. And I'm just going to arrange things a bit. Change the color of this one. And of course, I also need to trigger the beam right here. I don't want to trigger it back from where it was from. I think that's correct. Hopefully I didn't make any mistakes. I'm going to save. I'm also going to do the same thing I did before, which is simply check it with physics on. Let's zoom in here, Control P, and just watch the pipe movement a few times. I'll speed this up in the video playback. The spawn point is different each time. The destination position is different each time. I'm going to go ahead and copy and replace the old flow graph that's on the other 3 pipes. Save, F11, and test. And we should start to see some real randomization that each pair of pipes is on a slightly different path. At this point, you could also tweak your pipe speed settings. Now that we really have the full game loop working, this is a good time to start tweaking the difficulty of your game and customize it to your preferences. I see that I forgot to do one simple thing, which is to put our dynamic pipe speed in. We still have this hard-coded value of 5. Unfortunately, I forgot to do that before we copied all these graphs over, but that's okay. I'm going to make a bit of space here. And what I want to do here is simply retrieve the value of our horizontal pipe speed right here. Since that changes every time I score a point, it's dynamic. I need to check it every frame of the game, which is why I'm using GameToken instead of GameTokenGet. And whatever that value is, I'm simply going to feed it into here as my speed. I'm going to gamble that this is working fine and go ahead and copy this entire thing to my other pipes. Save, F11 to test. And now we should see these pipes speeding up every time I score a point. Right now it's subtle. In order to make the testing process easier, you might temporarily want to change the value from the 0.3 that I used to a bigger number so you can really see a dramatic increase in speed on every score. But I can already feel that things are moving faster and faster. The game is getting more and more challenging. And it's interesting to see that even though we're not doing anything complicated with this vertical pipe movement, we don't have sine waves or anything, it still looks pretty dynamic. Now there's one subtle problem that we're having that it may take you a while to notice. I'm just going to play the game and just watch the pipe movement as our speed increases. If you look closely, you'll notice that the horizontal spacing between the pipes is not perfectly even. It seems to be drifting. Sometimes the pipes get bunched together. Sometimes there seems to be extra space between them. We know that we're adjusting the velocity dynamically for all of them. We know that the spacing is always 15 meters. So the question is, why is this happening? I'm going to put an illustration on the screen and try and show the very simple geometric reason why this is happening. If you're sort of mathematically or geometrically inclined, you probably already figured it out. So here's my AI start and my AI end. In the past, I've been traveling in a straight line across like this. Now what we've added is randomization of both the AI end position and the AI start position. So as an example, let's say we end up with the AI end being higher and the AI start being lowered. And now I need to draw a path between the two of those. Now what I'm going to do is rotate this so it's parallel to the other one. This is the new journey our pipe has to take now. And you can probably already see where I'm going with this, which is that as soon as this becomes an angle, instead of a straight line, the path becomes longer. But the problem is we're still using the exact same pipe speed. the pipe that's traveling on this white path doesn't have as far to go, so it starts catching up to the pipe that has to make this longer journey, and they get crowded together. So what are we going to do about it? Well, we have to adjust the pipe speed based on the actual distance it has to cover. So this just involves our pipe movement right here, and it involves this speed here. So instead of simply feeding this here, we're going to need to create an adjusted value by checking the actual distance we have to travel. And we know what that distance is once we've finished randomizing our destination. So I'm going to make a bunch of space between here and here, because there's going to be quite a bit of math involved. I know it sounds scary, but it isn't going to be too bad. It's more just keeping track of everything we're trying to do here that's a bit challenging. So we need to measure something. Specifically, we need to measure the distance between two three-dimensional coordinates, and those, of course, are vec3s. So there's a good chance we're going to need something here in this vec3 group. Well, as it turns out, there's a node that measures distance between vec3 coordinates, and it's called magnitude vec3. So I'm going to go ahead and drag it on there. The next thing is I need to know where I'm going and where I am. Well, where I am now is simply the position of the graph entity. So I'm going to do a get pause, assign the graph entity, and I'm going to trigger this after setting my end position has been calculated. So that's the first thing that's got to happen. Next thing is I need to know where I'm going. Well, that's the position I just created right here. And I've got to subtract the two of those. So I'm going to subtract one vec3 from another. So I'm going to feed where I'm going into A and where I am now into B, and then use my magnitude vec3 to actually calculate the length of that vector. I'm going to add a comment to help make this clear, which is what these two nodes are doing. Now that I've got that distance, I need to compare that to the straight line distance, because if I subtract one from another and multiply that times my speed, that's going to give me my adjusted speed. Well, an easy way to do that is simply ignore the difference in the z, in the height, and just look at the x of where the pipe is now to the x of where I'm going. So that suggests I need to pull apart my vec3, and that's my friend from vec3. There's my start position. I want to subtract one from another, and I'm just doing this on the x value. I'm not even looking at y and z. So I can use a simple math subtract. Now that I have these two, I'm going to divide this into this, and that's going to give me my speed factor. And then what I need to do is multiply that times this speed. And that's going to give me my adjusted speed. I hope this makes sense. It's a little bit tricky to follow, so if you need to stop and think about it for a while, go right ahead. There's also explanations in the course book that might help you. So the only way I'm going to see whether this is working and solving the crowding and the spacing problem is if I put it on all of the pipes. So I'm actually going to copy it to all 4 sets of pipes and test them all at the same time. Save, F11, and let's play. And what I should have, if you look very closely, you may notice that the pipes are traveling at subtly different speeds, but the spacing is always perfectly even. No crowding, no spacing.